What? What? I'm laughing costs $10 now, Maddie. You owe me $10. That's it. That's now 20. You can. That's what they were saying.
I literally, guys, you do realize that if you do an AI draw and you try to create something in Dolly.
We're doing stuff.
Okay, so I hear so you got f of x equal to x squared minus 2x plus 4 over x minus 2. You can find a lot of information out of original questions. You can find x-intercept. You can find y-intercept. You can find domain. You can find vertical asymptote. And you can find horizontal asymptote. And you can find slant asymptote. Now, this is the first time I introduce you slant asymptote. I'm not going to test you on it. I'm going to be very straightforward, but curve sketching is probably one of the things that you're not going to test. You're not going to get AP exam question out of like just draw a graph. But I want you to be prepared for, let's say, UCF. UCF final exam has a curve sketching. So you need to know how to do everything. So rather than just say, hey, I only teach you for the College Board, which is not good enough. Even an odd function. So you can actually find all the information from all the stuff. So what I'm going to do is I'm going to find x-intercept. But x-intercept basically just make sure it's y equal to 0. So if I find x-intercept, it's just y equal to 0. So it'll be 0 equal to x squared minus 2x plus 4 over x minus 2. But the x minus 2 doesn't matter because you can multiply both sides by x minus 2. That's going to go away. So basically just only the numerator equal to 0. Now in here, you're supposed to be able to factor, but if you cannot factor, what do? Quadratic formula. Yeah, but the quadratic formula, you end up to look at the discriminant. Discriminant is negative, then that means there is no x-intercept. So I'm just going to check the discriminant. I'm not going to spend too much time on it. So that is going to, if it's none, if it is, then I can finish the quadratic formula. So it'll be 4 minus 4 times 1 times 4. And this is square root of negative 12, which is, you have no roots. So there are none for x-intercept, because you can have a non-x-intercept. Actually, a lot of function has no x-intercepts, like 1 over x has no x-intercept. Now y-intercept is very easy to analyze. Just plug in 0 for x, which is 0 comma negative 2. Domain. So Catherine, you're not here last week. Domain is basically you set denominator cannot equal to 0. So domain set denominator can equal to 0. So it'll be x minus 2 cannot equal to 0. And just solve like a normal equation, except x cannot equal to 2. Does that help you? Then that's going to be negative infinity to infinite, negative infinity to 2. And then 2 to infinity. And the vertical asymptote, well, vertical asymptote usually is you set denominator equal to 0 already. You already know how to find vertical asymptote, which is the same thing as how to find domain, except it's equal to, is that not equal to. So it'll be x minus 2 equal to 0, so it'll be x equal to 2. Is that okay? So horizontal asymptote. A lot of people say, how do I find horizontal asymptote? In this case, you want to say x approach infinity, because you want to find out what happened x equal to infinity. Now, remember yesterday, question 2, question 1, I think, your homework, that graph actually go through the horizontal asymptote. And you're like, why did it go through a horizontal asymptote? Because the definition of horizontal asymptote is when limit x approach infinity, right? In the middle region, it doesn't matter. Like, in middle type, like, you know, you can. I told you guys that horizontal asymptote is like eventually gay. Eventually you turn to gay. In mid part of your life, you can have experience this and that, and then at the end you say, no, I'm owning this. Chase. Okay. So x squared minus 2x plus 4 over x minus 2. And you can divide it by the highest degree on the bottom, which is x here, which is limit x approaching infinity. That's going to be x minus 2 plus 4 over x over 1 minus 2 over x. I divided by highest degree denominator, so I can reach infinity. If I reach infinity, this will be infinity minus 2 plus 0 over 1 minus 0. Why? Because this is going to go to 0. This is going to go 0. Eventually, this is going to be infinity. If the graph is going to go infinite, there is no horizontal asymptote. So there is none here. Even though all the work, you're going to say, there is not applicable here. Am I going too fast?
What if it's negative?
If it goes to negative infinity, same thing.
Okay.
Because if you keep on going down, you should check both, but in this case, it's both gonna be the same. It's gonna be negative infinity and positive infinity. So there is no horizontal asymptote.
Are there cases where one has the horizontal asymptote and the other one doesn't?
It is possible. It is possible. But I rarely see those. But I think it's very interesting. See if you can build one up to show me. But I haven't seen it yet.
I know the shape, but I can't think of what it's
Yeah,
called.
if something like this.
Yeah.
Well, like
I forgot what.
just like e to the x.
Oh,
E to the x is like that. One side has asymptote and the other side has horizontal asymptote.
Yeah.
Slant asymptote. Here's the main character of the day. So slant. Now, am I gonna test you for slant? Probably not. But I still have to teach you because just in case. So what you're gonna do is a long division. X and x squared minus 2x. Again, subtracting, this is gonna be 0, 0, and 4. So this is equal to x plus 4 over x minus 2. Now, this is your slant asymptote right here. This is a slant. Not worry about remainder. And so y equal to x is your slant asymptote. Is this even odd? Well, this is neither function, so there's no symmetry. So just by first original function, you can find a lot of things going on here. Now, what kind of thing I can go on? I'm going to go ahead and graph it. We know there's a vertical asymptote at 2. We know also another asymptote like this. Now, I think last year, I think Cooper really emphasized on graphing. Like he probably give you like rational function, ask you to graph on the test. I would assume so, because he's a calculus teacher at heart, so he would know like graphing is really important. So he will actually ask that. Now all these gonna be like, okay, you just do this, it should be fine. Yeah. So the perspective are different between two. Now I'm gonna give you the first derivative as well. This is a y-intercept is at 0, -2. So 0, -2 is right here. Now, if you normally, you should be able to come out a graph like this. If your teacher is probably gonna say this 2 quadrant will be good enough. As long as you plug in a value, if it is value there, they are pretty much just gonna go toward the asymptote. The asymptote is like a strong current. Imagine you're a boat, right? When you flow into the strong current, it's gonna follow the current. Right, so it's the same situation. Now, how much time I have? 3 minutes? Okay, so I'm gonna give you the first derivative here. The first derivative is x times x minus 4 over x minus 2 squared. The second derivative of this, you gotta find it by yourself because you practice also taking derivative on the test. So this one I'm gonna do 0 and 4. Why I don't do 2? I can do 2, but it's fine. I'm gonna do 2. So x and x minus 4. So I hear it's always positive. Doesn't matter what value you plug in because x minus 2 squared result is always positive. Now this one's going to be negative, positive, positive, positive. This one's going to be negative, 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 positive. So it's positive, negative, negative, positive. So by seeing that, you already see this is going to go up, this come back down, and there is a minimum here. So if I plug in f of 4, I believe I'll get 6. That means I plug in original functions, and I'm going to get 6. So 4 and 6 is going to be right here, this point here. I'm going to do a number line test here, 2. Before 2 is going to be concave down. After 2 is concave up, which is I'm going to sketch this graph, concave down. And it's increasing to 0 and decreasing to that. And this is going to be like this. And that's like that. And basically, you finish your graphing. Concave up, concave down. This time just have slant asymptote. I feel like this is actually easier than yesterday's. If you know how to do long division, this is actually easier than yesterday. Just need to do that slant asymptote part. Slant asymptote and horizontal asymptote cannot coexist. They usually can exist one, but not the other. And yeah, that's it. That's it for today.
And can you have an asymptote that's just like this for everyone?
Yes, you can. So if you do a long division and result is x squared, you can have a second degree asymptote. So they don't call it parabola asymptote, they call it second degree. So technically you can have x to the third as asymptote as well.
And
Yeah.
so on.
Yeah. It depends on your long division. Whatever you divide it out.
It's like a game.
Would you like me to
Everybody got this.
would you like help with the test or no? English.